In this video we are going to discuss about the Kepler's laws of planetary motion. Kepler introduced three laws. The first law is that every planet moves in an elliptical orbit, with Sun at one of the foci or foci, or the plural form of focus or foci. Now this is elliptical shape. This is the major axis. This one is known as the minor axis. This is one focus. This is one focus. We have taken, or Kepler took, the Sun to be at one of the focus, and the Earth or any other planet will rotate in an elliptical orbit with Sun at one of the foci. Now we all know that when the Earth is in this position, this is known as aphelion, and this position is known as the perihelion. The speed of the Earth at this point is more because the distance is less, the gravitational attraction is more, hence the conversion of that force into centripetal force will lead to a large velocity. Hence the movement of the Earth will be very fast, which is opposite in this position. The distance of the Earth from this position is very large, hence the attraction force is small, and the conversion of mv square by 12 leads to a very small value of v. Hence the Earth moves slowly in this position. This position is known as the winter region, and this position is the summer region. Now moving on to the second law. The first law is just a hypothetical case or a case that has got no mathematical formulation. You can find out the eccentricity value of this ellipse that you will study in mathematics. We know that eccentricity E is less than 1 for ellipse, equal to 1 for parabola, and greater than 1 in hyperbola. Now second law is we have to draw the ellipse once again. We take the Sun to be here and the Earth or any other planet to be here. Now if the Earth moves from this position to this position in a time interval of t, or delta t as you may call it, and join the radius vectors of these two positions, the area here will be same as the area covered by when the planet is moving from this position to this position in the same time interval t. This was the time interval t, and this is also the same time interval t. Again we join these 2 points, and the area swept out by the area, the line joining the Sun and a planet, it sweeps out equal areas in equal intervals of time. These areas are equal areas and equal intervals of time. That is, the aerial velocity of the planet is constant. Now aerial means area L. Aerial velocity is constant. Now proof means proof of this second law. Taking the orbit of the Earth to be a circle, we can prove the second law. This is the position of the Sun, and let us suppose the position of the Earth is here. It moves from position P to position Q. Join these two lines. Now the area swept out this in a time interval of t. Now we all know what is the formula. This is R, this is a small angle d theta. So S is equal to R d theta. Now if we take this to be a triangle, the positions P and Q are very close to each other. We can take the curve to be almost a straight line and take the full diagram to be that of a triangle. Now the area of a triangle means it is half into base. Base means R into altitude means r d theta. r d theta. That means r square by 2 d theta. We can write this as a, so half of r square d theta, let this be dA, not a, dA. Now dA by dt, the shift in this positions from P to Q, it takes a time of dt. So ddt of half r square d theta. Half r square is a constant and d theta by dt. Now what is d theta by dt? From circular motion we know d theta by dt means is equal to omega. Now the orbit is circular. As we have stated, the orbit we have taken it to be circular. As the orbit is circular, so r is constant. Therefore r is constant. And also omega of the earth, omega means 2 pi by t, that means time period for one complete rotation, that is fixed. Hence the value of omega will also be fixed. So this is also a constant value. So here we can write dA by dt becomes constant. From this expression we can say that area swept out in unit time, by the radius vector of the earth is constant. Now coming to the third law of Kepler, the square of the time period of revolution of a planet is directly proportional to the cube of the length of semi-major axis of elliptical orbit. Now this law is very, very important because questions are asked from this, and also mathematical derivation problems are given which you have to solve using this third law, with the help of this third law. In short, we can write t square proportional to r cube or small r cube. That means we take this to be a circular orbit and not an elliptical orbit. Concept about the elliptical orbit will need a much more detailed explanation, which we'll get in the higher studies and not in class 11-12. So this r can be the radius of a circular orbit. Now the time period t, that means time taken to complete one revolution, and r is the distance or the radius of the orbit of the planet. Now how to prove this? Proof is very simple. That is, we can take, if this is the sun, this is the earth, the attraction force between these two is gmm by r square is equal to mv square by r. If the particle or if the planet rotates, that means it has to get a centripetal force towards the center, which it gets as this gmm by r square force, that is the attraction force, gets converted to the centripetal force. Hence the earth or the particle revolves in a circular orbit around the sun. Now solving this, we can get the value of v is equal to square root of gm by r. Now we can take this to be small r also, and sorry, this is small r. So gm by smaller. Now from this equation we can also find out the value of omega. Omega means v by r, that means equals to square root of gm by smaller. Now v is equal to 2 pi r by t. Now why did you write this equation? 2 pi r means one revolution, and the time taken by one revolution to complete one revolution is t. So s by t is the velocity, or rather t is equal to 2 pi r by v. We replace the value of v in this equation. Which v? This v. So we get 2 pi r by v means square root of r by gm. That means 1 by v. It will be numerator goes to the denominator and denominator to numerator, r by gm. Now we take this r inside, 2 pi, r gets inside, so r square and 1 r already existed, 2 becomes r cube by gm. So t is 2 pi square root of r cube by gm. Now squaring both sides, t square is equal to 4 pi square r cube by gm. Now 4 pi square gm is a constant term. So from this we can write t square proportional to r cube. If 4 pi square gm we know are all constants, so t square varies as the cube of the radius of the orbit. Now we are going to discuss about escape velocity, a very important topic. Preliminary things that we know, that is when an object is thrown vertically upwards, it moves up to a certain height and then comes down to the surface. It moves to a certain height, comes down to the surface due to the gravitational pull of the earth. Now at the maximum height, the particle released from here, at this maximum height, what happens? The velocity of the object becomes 0. V becomes 0. Now more the projection velocity, if we project, the velocity of projection, let it be u. Now if we can increase the value of u more and more, greater will be the height attained. Now before the velocity becomes 0, the height attained will be more. Now if the velocity of projection continuously increases, a stage is reached when the velocity of the object does not become 0. This implies that it does not return to the Earth's surface. It flies off. At this state, the object recedes from the Earth's surface and the force of gravity also decreases to almost a negligible value. Hence, it can be said that the body reaches an infinite distance from the Earth. We are continuously increasing the value of u so that it reaches an infinite distance from the Earth. Now the minimum velocity of projection required for this to happen is called the escape velocity. The minimum velocity of projection, this is known as the velocity of projection. The minimum velocity of projection required for this to happen. What to happen? That the body will reach an infinite distance from the Earth. The body is not going to come back to the Earth because it is reaching a point where there is no gravitational force. It is reaching a point where there is no gravitational force. The body returns back to the Earth because of the gravitational force. So, by definition, we can say that the minimum velocity, by definition, we can say the minimum velocity of projection. The minimum velocity of projection from the Earth's surface, that means it can be Earth, it can be any other planet, it can be satellite, anything, such that it can escape the gravitational attraction of that planet or Earth, as we may say. So the minimum velocity of projection for the particle to move out of gravitational attraction of Earth or any other planet, including satellites. So minimum value of projection of the particle to move out of the gravitational attraction of the Earth or any other planet, including satellites. Now let the mass of the Earth be m. Mass of this Earth be m. Now the radius of this Earth be r. Mass of the Earth is m and the radius is r. Now the force of gravity on a mass small m at a distance x from the center of the Earth. Let this be the position. This is a distance of x from the center of the center of the Earth. So we can write the force of gravity on a body of mass m. So the mass m is here, mass m is here. So force of gravity in a body of mass m at a distance x, this distance is x, from center of earth is equal to gmm by x square. Simple thing according to the Newton's law of attraction, gmm by x square. Now for a small displacement dx of the body against the force of gravity, we are trying to move this body by a small amount dx against the force of attraction, because the force of attraction tries to pull the body backward. We are trying to move the body in the opposite direction. So we can write that for a small displacement, for a very small displacement dx, this is dx, the work done. Now what is the work done? The force was gmm by x square into dx. Work done means force into displacement. This was the force and dx is the displacement. Now this is the work required or work done for a very small amount of displacement dx. Now for an infinite displacement, the expression becomes from r to infinity. Why from r? Because we are releasing the particle from the earth's surface, which is already at a height of r from the center of the earth. So gmm by x square into dx. Now we all know what is dx by x square. Gmm is constant, it comes out of the integration. So dx by x square means minus 1 by x, limit from infinity to r. So you replace the value of infinity first, minus of minus 1 by r, that is gmm. 1 by infinity means 0, so minus and minus becomes plus, so 1 by r. So gmm by r. Now this is expression for the escape velocity. This is the escape work, or rather the work done for escape of the body. Now how do we realize it? Realize it by applying a kinetic energy or a kinetic force to the body. Now if you can equate this to half mv square is equal to gmm by r, because already we have found out and we have already understood the fact that this is the work that has to be done by the particle to move out of the gravitational field. Now realization of that needs a flow of energy, or rather a kinetic energy, like half mv square. Now equating these two, we get ve, velocity, is equal to 2 gm by r. Both the small m's get cancelled from both sides, square root of 2 gm by r. Now replacing gm as gr square from, what is the expression? G was gm by r square, so gm is equal to gr square. So velocity is equal to 2 gm means 2 gr square by r, that means square root of 2 gr. So velocity escape can also be written as 2 gr. This is the expression you have to use for any other planet, and if we are given a problem related to the earth, then we can use this one also, but I think this will be more useful. Now replacing the value of this 9.8 r as 6400 into 10 to the power 3 meters, we get a value of 11.2 kilometers per second. So this is the value of the escape velocity of the earth, which varies from planet to planet. Now one question may come that this is the earth, we are releasing the particle in this direction, but another particle will be released in this direction at an angle of theta from the first. First particle moves out from the surface like this, another particle is released at an angle of theta with the first direction. Now escape velocity of the first particle and escape velocity of the second particle, are they same or different? Absolutely they are the same, because the expression of escape velocity does not bear any term like theta or angle. So this will also be VE, this will also be VE, velocity 11.2 kilometers per second.